Let us start. In previous class, we have discussed about some chemical properties of aldehydes and ketones. One property of aldehyde is remains. That one is, see here, that is electrophilic substitution. Electrophilic substitution reaction. It is the last chemical property of aldehydes and ketones. Aromatic aldehydes and ketones undergo electrophilic substitution reaction such as nitration, sulfonation, and halogenation. Nitration means addition of NO2 group, sulfonation, addition of sulfate group, and halogenation, addition of halogen group element, as like that. That is known as electrophilic substitution reaction. Electrophilic substitution reaction means nitration, sulfonation, halogenation, as like that. See here, benzaldehyde. Benzene ring directly bonded with a aldehydic group, so it have a name, that is benzaldehyde. When treated with HNO3, that is concentrate nitric acid. Concentrate nitric acid in presence of concentrate sulfuric acid. The mixture of that sulfuric acid and nitric acid is also known as nitrating mixture. It is also known as nitrating mixture. We get meta-nitrobenzaldehyde. Meta-nitrobenzaldehyde. How it is formed? In a benzene ring, there is 6 hydrogen atoms at each corner or at each carbon atom. Then one nitro group. That nitro group is replaced at one hydrogen atom. That nitro group is replaced at one hydrogen atom, and that removed hydrogen atom combined with that OH group, we get a water molecule. In place of one hydrogen, that nitro group is substituted, and that reaction is known as electrophilic substitution reaction. Then we get meta-nitrobenzaldehyde. It is the position of benzene, that is para, meta, and artho. See here, if the nitro group is bonding at that position, then that position is known as artho position. You are already known about it. At the third position, then it is a meta. At the fourth position, then it is a para position. In that way, the chemical properties of aldehydes and ketones are completed. Then after, the last point of that chapter, that is chemical properties of carboxylic acids. In that reaction, in that chapter, only reactions are very important. So you must need to practice the reactions only. Only reactions need to practice. How to practice the reactions? I will giving you in each reaction, that is the general reaction, GR indicated. GR means general reaction. You must remember that a general reaction, then you can solve any reaction. It is a formula as like in math. मॅथेमॅटिक्स मध्ये जसा फॉर्म्युला असतो तसं ही जनरल रिएक्शन आहे. ही जनरल रिएक्शन जर तुमच्या लक्षात असेल तर तुम्ही कसलीही रिएक्शन त्याच्या आधारे पूर्ण करू शकता. सी हियर द केमिकल प्रॉपर्टीज ऑफ कार्बोक्सिलिक ऍसिड. फर्स्ट, फॉर्मेशन ऑफ acyl chloride. Formation of acyl chloride or reaction with PCl3, PCl5, SOCl2. Reaction of carboxylic acid with PCl3, PCl5 and SOCl2. Carboxylic acids on heating with PCl3, PCl5 and SOCl2 separately give corresponding acyl chloride. Corresponding means the how many carbon atoms are present in a reactant, then concerned carbon atoms will be produced in a product. म्हणजे काय, की जितके रिएक्टंट मध्ये कार्बन ॲटमची चेन आहे तेवढ्याच कार्बन ॲटमची चेन जर प्रॉडक्ट मध्ये मिळत असेल तर त्याला आपण काय म्हणतो, करस्पॉन्डिंग म्हणतो. See here general reaction, that is RCOOH. It is known as carboxylic acid because COH is a carboxylic group. RCOOH when treated with SOCl2, we get RCOCl with byproduct SO2 and HCl. How it is formed? In that reaction, the replacement of OH group by Cl, OH group is replaced by chlorine atom. Then we get RCOCl, that is known as acyl chloride. It is known as acyl chloride. See here, that carboxylic acid when treated with SOCl2, one chlorine is replaced in place of that hydroxyl group. Then we get a acyl chloride. Then the remaining part, one oxygen is combined with that SO, that is sulfur monoxide, we get sulfur dioxide as a byproduct. And the remaining hydrogen atom is combined with one chlorine atom, because one chlorine is combined with that carbon atom, the remaining chlorine is combined with that hydrogen atom. Then we get HCl as like that. See here one example, then you must be clear the idea how acyl chlorides are prepared. For example, acetic acid. It is a acetic acid. SOCl2 when, that is thionyl chloride, when treated with acetic acid, we get acetyl chloride. We get acetyl chloride. How it is formed? There is the replacement of one hydroxyl group by a Cl, that is the chlorine group. Then we get acetyl chloride. The removed OH group, the oxygen is combined with that SO, we get SO2. And one hydrogen atom combined with the remaining chlorine, we get HCl as like that. Then after the second example, that is carboxylic acid, three molecules of carboxylic acid when treated with PCl3, it is also the replacement of OH group by a Cl group. Then what happens? We get a acyl chloride. Three molecules of carboxylic acid required to replace three chlorine atoms. Then these three chlorine atoms are replaced in place of three hydroxyl groups. There is three hydroxyl group because it is a thrice. That means it contains three hydroxyl groups which is replaced by three chlorine atoms. Then three hydroxyl groups are free. That three hydroxyl groups are combined with phosphorus, we get phosphorus trihydroxyl, that is POH thrice, as like that. For example, see here, that is three acetic acids when treated with PCl3, we get acetyl chloride with POOH thrice, sorry, POH thrice. The next reaction, that is RCOOH, carboxylic acid, when treated with PCl5, phosphorus pentachloride. On heating, we get acyl chloride in same manner, that is the replacement of OH group by a chlorine atom. One chlorine is replaced here, then it remains four chlorine atoms. How many chlorine atoms here? There is five chlorine atoms. One chlorine is replaced in place of OH, then remaining four chlorine atoms are four chlorine atoms are remain here. In between four, the three chlorine atoms we get as like that. That oxygen combined with phosphorus and three chlorine atom, that is POCl3. The remaining one chlorine atom is combined with that hydrogen atom, we get a HCl as like that. As like the reaction will be balanced. For example, acetic acid when treated with phosphorus pentachloride, we get acetyl chloride with POCl3 and HCl. The next chemical property of carboxylic acid, that is formation of amide. formation of amide, or it is known as a reaction with ammonia. What is the action of ammonia on carboxylic acid? As like that question on that bit. Carboxylic acid react with ammonia to form ammonium oxalate salt, which on further strong heating or more heating decomposes to give acid amide. On decomposes, it gives acid amide. See here, there is a general reaction. RCOOH, that is carboxylic acid, when treated with NH3, ammonium oxalate is formed. What happens? That NH3 directly add to that carboxylic acid. We get RCOONH4 as like that. It is known as ammonium oxalate. On heating, there is a removal of one water molecule. We get acid amide. There is a removal of one water molecule. We get acid amide. Here is NH4. In between NH4, there is 4 hydrogen atom. In between in that 4 hydrogen, 2 hydrogens are combined with 1 oxygen atom. We get a water molecule. Then the remaining part is known as acid amide, that is RCONH2. For example, acetic acid, when treated with NH3, we get ammonium acetate. That 2 hydrogen atoms combined with that oxygen atom, 1 water molecule is removed. See here, minus H2O. 1 water molecule is removed. On heating, it decomposes to form acetamide, as like that. And the next chemical property, that is formation of acid anhydride, or a reaction with P2O5 in presence of sulfuric acid, concentrated sulfuric acid. Here, monocarboxylic acids on heating with strong dehydrating agent like P2O5 or in presence of H2SO4 give acid anhydride, but it is a reversible reaction. Here, the reaction is reversible. It is very important. General reaction. There is 2 molecules of carboxylic acid. I will write as like a structure because to understand better how the acid anhydride is formed. Here, RCOOH plus RCOOH मी इथं खाली लिहिलेलं आहे RCOOH. There is 2 molecules of carboxylic acid, RCOOH. When heating in presence of P2O5, we get as like that. That is the removal of one water molecule, we get acid anhydride. Acid anhydride. See here, one water molecule is removed when heating in presence of P2O5. Then we get acid anhydride as like that. RCOO, RCO. That is acid anhydride. But it is a reversible reaction because the removed hydrogen atom further react with that acid anhydride. We get a reactant reversely, that is carboxylic acid. Then for better yield by heating sodium carboxylate with acyl chloride. To get a better product, you must take the reaction as like that. That is the general reaction. Sodium carboxylate, that is sodium salt of carboxylic acid. It is known as sodium salt of carboxylic acid because in place of carboxylic acid, the hydrogen atom is replaced by one sodium atom. So it is known as sodium salt of carboxylic acid or sodium oxalate. When treated with acyl chloride, that is RCOCl, acyl chloride, we get a combining product, that is acid anhydride. How it is formed? That sodium atom is combined with that chlorine atom, and that oxygen atom is directly bonding with that oxygen. then we get RCOO COR as like that, and a byproduct that is NaCl. NaCl is combined, we get a byproduct sodium chloride. For example, sodium acetate CH3COONA, or it is a sodium salt of acetic acid. It is also known as sodium salt of acetic acid. When treated with acetyl chloride, on heating we get acetic anhydride with byproduct sodium chloride. The next reaction, decarboxylation of carboxylic acids. Decarboxylation of carboxylic acids. Sodium salt of carboxylic acids. Sodium salt of carboxylic acids. Sorry, there will be some problem in a network.